Last year, we decided to do something different during the Gartner Application Architecture Development and Integration Summit in Sydney. We want to do demos that are memorable. We want to attract summit goers to come to our stand. And at the same time, we want to show people how they can use Red Hat technology to implement some real-life use cases. So we decided to do demos involving robots. And these are the two use cases that we have implemented. The first one involved 3 robots. I control, or the attendee control the robot using a web-based interface. And while it's moving around, it's sending all its movement to a particular topic on the MQTT server. I have a second robot which subscribes to the same topic. That means whatever movement the first robot is doing, the second robot will mimic it or doing the same thing. Not just that, I am also using Fields Online, a citizen integration tool from Red Hat, to create an integration which subscribe to the same movement topic. Retrieve the information, the movement that is, and then persist that in Kafka. And then I created another Fields Online integration to retrieve the data or movement from Kafka topic and put it into a database. Then I created a web-based interface which allows the user to retrieve the movement by username and replay those movements on the third robot. So how is it related to real-life use case? Imagine we paste this MQTT server with a traditional message broker. Replace the robot with bank transactions. Then you're dumping all these bank transactions via the traditional message broker, persist that in Kafka, and then you take that and dump it into a data warehouse. And then you use your analytics programs to analyze the data in the data warehouse and extract whatever you want, metrics from it, for example. And the second use case we have is to do AI and machine learning. It involves training a robot to dance to the music. You have to go through a training process. Right, we play some music and at the same time, do some movement with the robot. So what the training does is that it actually breaks up the music into amplitude and frequency and try to build a pattern, recognize patterns of movement associated with the change in amplitude and also the frequency. So after the training process, when you play the same song or some different song, the robot will appear to be dancing to the music by identifying all this behavior or these patterns in the amplitude, change in amplitude and also in frequency. And these are the robots that were used in the Gartner Summit. Today I'm going to talk about evolution of these robots. So from prototype to Gen 1 robots, these are the robots I call Gen 1 robots, and then the latest robot which I call Gen 2 robots. It all started with this robot. His name is Max. It's a he-meccano-max. So I actually added a Linux-based single-board computer on it with a camera and also a laser pointer. And you can see that its face is actually an LED display. You can display the happy face, sad face, or any face that you want, and it can also display text on it. It's really impressive looking robot. The difficulty with that is that I have to actually reverse engineer all the commands that is required to actually control the motors. You can actually find out more about how I did that on this particular project that I created on Hackaday.io. As I said earlier, it's a very impressive robot. I like it very much. Unfortunately, I cannot use it in the demo because it's too big. It's about 1 foot tall, about 2 or 3 pounds heavy, and it's very difficult to carry 3 or 4 of these around to conferences and forums. And with that prompted me to look for something smaller, so I end up choosing this one. It's a Pololu Sumo robot. It's a palm-sized robot. And in order for me to control it remotely using Wi-Fi, I have to actually create a bespoke Wi-Fi extension. You can see this thing here. It's based on the ESP32 chip, right? So the combination worked pretty well in our Gartner demo. And lots of our colleagues all over the world want to replicate this particular robot demos. But the issue is that it requires a bespoke Wi-Fi extension for people who don't have electronic or mecha experience. It could be challenging. So that's what prompted me to look for a second generation robot, which are off the shelf. That means that you don't need to do anything or modify the hardware for it to work. And finally, I found this. It's based on the M5 Stack Rover C, which is robot, you see here. And the controller is M5 Stick C, which is the orange box, rectangle at the top. It has built-in batteries, and also it has a display. So you can see that I'm in here. I'm actually displaying the IP address it's get assigned to by DHCP, and also it shows the last remote command that was being executed for debugging purposes. Next, I'm going to show you videos of each of these robots from prototype to generation 2. This is the prototype Max. You can see that laser pointer there. On the left hand side is the original movement, and on the left hand side is the playback movement. I'm starting to experiment with a playback function. In here, because I only got one robot, and I'm actually saving all these movement commands into a file and then pay back that file on the second robot. You can see that they're almost synchronized because they're paying exactly the same movement. You can see that. You can see the face expression of the robot is very interesting. And also, I said earlier, it can actually display text in here. You can see the moving text in here. As I said, I like this robot, just that it's too big and too heavy to take it with me to exhibitions. And here's the Generation 1 robot. They are actually controlled by an attendee to the forum. And well, you can see he's controlling the one in the front, and the second one just mimics his movement. You see there's a slight time lag because it's sending the movement to a remote MQTT server, and the second one to receive it from that remote MQTT server. This is the Generation 3 robot. I'm just going to show you one feature it has over Generation 1. Just wait for it. Turn. This is it, moving sideways. Because it has mechanism wheels, it can move sideways. By the way, I have all the source code, all the applications, even the firmware for the robots. They are all on my GitHub account. I put links to the video. Thank you for watching.